Welcome back to Virtual Chemistry, Lesson 3. Today we're going to be talking about Boyle's Law. So let's talk about Boyle's Law, the relationship between pressure and volume. All right, so Boyle's Law is really the relationship between pressure and volume. It's how volume impacts pressure, or like what I like to say is how pressure depends on volume, because pressure is your dependent variable. They are inversely proportional. So if I were to summarize Boyle's Law concisely, it would be pressure and volume are inversely proportional. N and T are frozen, which means the number of particles or the number of moles of gas, and temperature are frozen, or they are constant. And then the formula that we'll be using to calculate anything with Boyle's Law will be P1 times V1 equals P2 times V2. So you can see here in this picture to the right that as we decrease the volume, right, we push this piston down, we are actually increasing the pressure, right? As one goes down, the other one goes up. Okay, that's an inverse proportion. Okay, so I really love this, this graph here because it shows us a really nice, active response to the change in volume. So as we change the volume, we change that piston, we push it down or we pull it up, you can see that our pressure increases. You can think about this as if you're holding a balloon and you start squeezing the balloon and you kind of start wincing and you're like, oh no, I don't know if that's the reason why you're wincing is because you're squeezing that balloon, you're decreasing the volume of the balloon. And so all the particles are pushing on the insides of the balloon, increasing the pressure inside the balloon, which eventually, if you squeeze it too hard, it's going to pop, right? So Boyle's Law is the reason why you don't like squeezing balloons too tightly. Anyway, so what I really like about this is as we push the piston down, you can see that pressure is increasing. And as we pull the piston out, pressure decreases. So again, this graph shows that not only number of particles are the same, right? No more particles are being added. The temperature is staying the same, so we've got our two constants. And as we change the volume, our pressure is impacted. So that is Boyle's Law in a nutshell. Let's go ahead and try a practice problem. So this is number 1 on your worksheet. I'll just have to move me around. Number 1 on your worksheet on page 6, the last page, it says the flexible container below is filled with gas and sealed with an adjustable top. The initial volume of the container is 10 liters, okay? And the gas pressure inside is 5 atm. Right off the bat, I'm looking at those numbers and I'm thinking, okay, I need to highlight those. I need to bring attention to those. So I know that I'm going to be using Boyle's Law. And so I'm going to highlight the two numbers that have been given to me, 10 liters and 5 atm. And you'll notice that for number 1, they also give you a picture of a piston with nothing inside it, but we assume that there's gas in there, okay? A person reduces the volume 3 different times by pushing on the top. Use Boyle's Law to determine the pressure at 3 different locations. Okay, so I know that I'm going to be using Boyle's Law because it's the Boyle's Law lesson, but also I've got volume, liters, and pressure, atm, and I know that I'm going to be plugging those 2 values into the equation here. So you'll see that I've got volume in dark red and pressure in light green, and I know that these 2 values go together because not only does the picture show that this container has 5 liters of gas at a pressure of 10 liters of gas at a pressure of 5 atm, but also you can see that they kind of are related to each other in the question. The initial volume of the container is 10 liters and the gas pressure inside is 5 atm. Okay, other things that I'm looking at. A person reduces the volume. Okay, so if we reduce the volume, that's going to be our second volume. And you'll notice that I have also circled or highlighted the volume of the second piston. And then we need to determine the pressure. Okay, so we're trying to find P2. So what I'm going to do is plug this into my equation. So 5 ATM times 10 liters equals X times 5 liters. And I'm going to go ahead and simplify that. So I have 50 equals 5X. And then isolate X by dividing both sides by 5. So your final answer is 10 ATM.